We're going to talk about how to find the volume of a right prism. And the first thing we want to do is discuss what volume is. And volume is how much space an object takes up in the real world, or how much it can hold, what its capacity is. Let me show you what I mean by that. Volume is a function of three different dimensions. And we're going to use this playing card as an example of the three dimensions. So right now we have the two of diamonds, and I'm going to move the two of diamonds. And here you can see two of the dimensions that we're going to be working with. That, of course, is the base and the height. And that's two dimensions. The third dimension that we deal with volume is how tall or how high an object is, or how deep it is. And what I mean by that is, if I now take this stack of cards, this is the third dimension, that particular height. In other words, if you think about it, it is the object's footprint, or its area, how much space it takes up in two dimensions, and then you multiply that by the third dimension, how tall it is. And the way that we do that is this, is we say that volume with a capital V, equals capital B, which is the area of the object in two dimensions, correct? This small b multiplied by that small h, and multiplied by the height, how tall or high or deep the prism is. All right, I'm going to pause here for a moment, and let's get ourselves a problem with some dimensions, and let's find the volume of a right prism. Okay, I now have two prisms here. The one on the left, A, is a rectangular prism, and the one on the right, B, is a cube. So let's start with A. And let's, of course, start with our formula, which is volume equals B, which represents the area, multiplied by the height. Okay, so for B, what does B equal here? Well, B is going to equal this 9. That's 9 feet this way by this 2. So I'm going to multiply 9 by 2, and B is going to equal 18 feet square. And then the question is, how tall is this prism? And it is, this dimension is 3. So this is just like the card in the sense that we had the flat face of it, the base of it, in this case 9 by 2, and then how high is the stack? The stack is 3 feet high. All right, so now I've got volume equals 18, that's my B, multiplied by 3. That's the height of this prism. And the volume of this prism is going to be 54 feet and cubed. And it's to the third power because we're dealing with 3 dimensions. Now, with a cube, you're going to use the same formula, except all of your numbers are going to be the same, as you can see here. The volume here, you've got a 3 by 3 cube multiplied by 3 feet high. So essentially, with a cube, it's just the one dimension to the third power. In other words, the volume of this cube is 27 feet cubed. And to go the long way, pardon me, I'm just going to slide over a little bit about that. The base here was 3 multiplied by 3. That's the base of the cube, 3 by 3. And that, of course, would have equaled 27 cubic feet. All right. And just taking you back through it, this would have been 27, pardon me, that's incorrect. That would have been 9 feet cubed. Calculation error, my fault. And this, of course, then would have been the base, which was 9 multiplied by the height, which was 3, and that's how I had 27 feet cubed. All right, that is how one finds the volume of a right prism.